In this video, we're going to learn the power to a power rule. This will be your third rule, kind of going off of the product of power and the quotient of power rule you already did. I know the names are very similar, but you really just examine power to a power means you're taking something to a power to another power, so two exponents. So you can apply the power to a power rule of exponents to algebraic expressions, and then you can apply the product of power, and it should actually say quotient of power and power to power rule simultaneously. So you can do three rules at once if needed. So far we've learned two exponents rules. In the previous video you learned the product of power rule, which is x to the m times x to the n, and you add your exponents. Quotient of power rule means you are dividing two with the same bases, and we subtract our exponents. And remember, we wrote them as repeated multiplication to help us out. We're still going to do that in this video. This will be kind of the last time I'm going to require it, unless I see in later work in class that you still struggle and you need to write things out. So let's take a look. When you have something to the second power, remember the powers tells me how many times to multiply. So it's saying take your base, which your base in this case is the entire 2 to the third. And then I need 2 to the third 2 times. So this means 2 to the third times 2 to the third, which can be written, that means 3 2's and 3 more 2's, which gives me 2 to the 6. Or another way you could write it out, you could write out your inside first. Some students like to do that. Square it, which means you have a total of, you have your base, the entire thing, because that entire thing's in parentheses, to get 2 to the 6. I don't care which way you write it, it is both correct. I'm actually going to do the second way on this next example. So 2 to the 4th means I have 4 2's inside. 2 times 2 times 2 times 2 to the third power. I need that 3 more times because I'm cubing that expression. Well, how many 2's do I have total? 2 to the 12th. And you should kind of see, hopefully, after these two examples, some of you might be able to see what rule is being applied. Where is the 6 coming from and where is the 12? So here I have 3x inside, and I want that 2 times. So I have 3x times 3x. Well, numbers, we always multiply. We have 3 times 3, which is 9. Then 2 x's. X times x is x squared. Now, on the inside, I have 2 3's, so this is 3 times 3. And then I have 3 x's. And I want that a total of 3 times. So I'm going to write it 2 more times. Alright, so we have that cubed. Again, the numbers, this is all multiplication, so I'm multiplying 3 times 3 times 3 times 3 times 3 times 3 6 times, which is 9 times 9 times 9. Let me get the calculator out. I know 9 times 9 is 81, and I just need to take it times one more 9. 729. So we have 729. And how many x's we have? 3 more and 3 more gives me a total of 9 to the, or x to the 9th. And then we can apply the same rule with fractions. If I have 2y to the w and I have it 2 times, this is 2y to the w, 2y divided by w. Sorry, I said this previous one wrong. It should be over the w. Alright, so we learned from the previous video, fractions we multiply across. So we have 2 times 2, which is 4. 2y's is y squared. Y times y is y, or w times w is w squared. And I am done. And I know I'm done is because I only have one base of each, and then I just have one single number unless it was a fraction that reduced all the way down. So here, if I want to write the inside out, I have 2 times 2 times 2, 3y's, 2x's, and I have that 2 more times. Alright, so then I figure out how many I have. I have, multiplying all my 2's together, so I have 2 times 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 2. Well, 2 times 2 times 2 is 8, so it's 8 times 8 times 8. 8 times 8 is 64. Let's go 64 times another 8. Gives me 512. Alright, and then look how many y's I have. I have a total of 9 y's in the numerator, and I have a total of 6 x's in the denominator. So we have the power to a power rule, and there's kind of 3 different ways you can look at it, but the rule kind of applies. Hopefully you've noticed what's been happening with the exponents. If you have x to the m to the n power, well, what's happening, the rule states that you have m times n. So if you look back here, 3 times 3 is y to the 9th. 3 times 2 is x to the 6th. 2 to the 3rd, that's 2 to the 9th, which is we had 9 2's, and then we calculated out to be 512. Or if you have it multiple things in here, so I have x to the m, y to the p, and I'm taking this to the n power. This is x to the mp, and y to the mn, and y to the pn. Sorry. And you're kind of distributing that n. Alright, and then lastly, if you have a fraction, so you have x to the m, y to the p, to the n power, you're still distributing, you're still multiplying it through to every exponent. That's x to the mn and y to the pn. Alright, so let's quickly go through a few examples. Again, we want to write this out as repeated multiplication, so you get used to this rule, and once I know you've mastered it, you can stop. So inside I have 4 f's, and I need that 3 times. Which gives me f to the 12th. On B, I have 6 h's. This one's going to take me a while to write out. And 2 k's in the bottom, and I need that a total of 5 times. So yes, going through right now. Sometimes it's going to take a while, but it will help you understand the rule in the long run. You're more likely to remember it. And you can use this strategy if you can't remember the rule, which sometimes happens as time goes on, but if you remember what exponents mean, it may help you figure out simplifying expressions. One more time. Alright, so let's write the answer over here. Alright, so these are all fractions being multiplied. So in my numerator I have all the h's. I have 6 plus 12, 18, 24, 30. So that's h to the 30th, which I can check because 6 times 5 is 30. 30. And k, 2, 4, 6, 8, 10. And I am done. So on C, I have 7 c to the 3rd. So that's 7 and 3 c's. And I have it one more time. 7 times 7 is 49. And then I have a total of 6 c's. Alright. We're going to skip D for now to make this video a little shorter. It's very similar to B, not much different. So if you didn't understand B, again, rewind the video and rewatch it. Alright, so on E, getting a little more complicated, and we're going to cross off F too. So this will be our last example. Write the inside, so I have 3m squared. You kind of treat this problem as two separate problems, but we're going to put it all together. So I have 3m squared, and I have that 4 times. So I need 4 sets of them. And then I have 2m to the 5th. So I'm not doing this problem, I can write it over here. 2 times. So I have 2 and 5 m's. Alright, so numbers we just multiply together. So you have 3 times 3 times 3 times 3, which is 81. So I know I have 81. And 2 times 2 is 4. So 81 times 4 is 324. And then how many m's? I have 2, 4, 6, 8. And then I have 10 here, so that's m to the 18th. Alright, to review, we have the power to a power rule, which what we do is end up multiplying exponents. So if m to the x to the m to the n, that means x to the m times n. And then you're kind of distributing to everyone. Everyone is included. And this is why I make you write it out, because a lot of students miss this. They leave out certain things that don't get the exponent, and then they end up getting it wrong. So hopefully this strategy will help prevent that. Reminder to do a reflection so you get credit for watching this video.